Hi, welcome back to another lesson with Domoji Math and Science. In today's lesson, we'll see implicit differentiation. I'll explain how to differentiate an implicit function. But before we get into that, I'll start by explaining what an implicit function is. I'll show you some examples. I'll show you how to solve them. Then we'll use this example to demonstrate how to solve a complete implicit function. That said, let's get into class. Implicit function is a function that is highly involving between x and y, where you cannot easily separate x from y. Such a function, you see it with the hyperbola. The function with the hyperbola tells us we have x squared minus y squared is equals to 1. In such cases, it is not easy to separate your y from x, either before differentiation or after differentiation. Now let's look at this example. If I have an equation of a parabola that tells me x squared plus y squared is equals to 25. Now, if I am to differentiate this function, this is an implicit function. The first thing I'll do is to differentiate x. I'll differentiate y squared, then I'll differentiate 25. Now, let's see how to go about this. To differentiate x squared, remember that we say that y is equals to, if y is equals to ax raised to power n, then my dy dx will be the same thing as an x raised to power n minus 1. We'll use this idea to differentiate x, so that the differential of x, of my x squared, let's write it down again, plus y squared, we say is equals to 25, so that the differential of this will be given as 2x plus, to differentiate y squared, I have 2, just same way here, we'll do 2, then my x raised to power n minus y, but here I have y squared. I'll pick one of the y as dy dx. Then I'll leave the other y dy dx is equals to 25. 25 obviously is a constant, and that is equals to 0. Now, so that my 2x now plus 2y dy dx is equals to 0. Now, 2y dy dx will be equals to minus 2x. So that dy dx will be equals to minus 2x over 2y. Divide both sides by 2. I'm left with minus x over y. Now, let's see our example for today. And with that, I'll be able to explain further on how to differentiate an implicit function. Now, our example says we have x raised to power 3 plus 3y plus y raised to power 3 plus 3xy squared. Like we did initially, we'll differentiate this on its own. We'll differentiate this, the y raised to power 3, and we'll also differentiate each of them. Now, to differentiate x raised to power 3, it should become 3x raised to power 2. Remember our formula, we say if y is equals to ax raised to power n, then dy dx will be equals to anx raised to power n minus 1. Now, so that if we use that, in differentiating x raised to power 3, my a here is 1, and my n here is what? Is 3. So I'll have 3x raised to power 2 plus, now to differentiate y raised to power 3. Because I'm differentiating y, I'll pick my 3, then I have 3 y's here. Let me put it that way. I'll pick one of these 3y. I'll be left with y raised to power 2. Then that y I have picked becomes dy dx. Now, plus, I have 3xy squared. This is where it becomes a little complicated, but if you follow me, it's very, very easy. Now, pick the 3 first. Then it becomes, I'll differentiate x. I'll keep y constant. If I differentiate x, x will become a 1. I'll keep y squared constant, that's y squared, plus I'll differentiate y raised to power 2, and I'll keep x constant. That is, x now, differentiating this is going to become 2. I have y raised to power 2, I'll keep one of the y, then the other becomes dy dx. Now bracket close, equals 8. 8 is a constant, and it becomes 0. So that this is the same thing as saying 3x squared plus 3 y squared dy dx plus, now let's open this bracket, 3 times y squared becomes 3y squared. 3 now we multiply the 2 plus 6xy dy dx is equals to 0. So that my final equation now becomes, let's pick this first, that's 3x squared plus 3y squared becomes 3x squared plus 3y squared dy dx plus, if I'm not mistaken, okay, 3y squared plus 3y squared plus 3y squared plus 6, let me check what I have there, xy dy dx is equals to 0, plus 6xy dy dx is equals to 0. Now let's collect like terms. I'll collect like terms for everywhere I have dy dx. So my 3x squared, this should go to the other side. I'll be left to 3y squared dy dx plus 6xy dy dx equals minus 3x squared minus 3y squared. Everywhere, every place I don't have the y dx, I've moved them to the other side, so that I can now collect my dy dx into 3y squared plus 6xy is the same thing as minus 3x squared minus 3y squared. So that dy dx will be the same thing as minus, now negative sign, with this negative sign I want to bring this out so that and I have a 3, I have a 3 is common, so I can bring 3 out. This is x squared plus y squared, bracket close, all over. Now 3 again is common, I want to bring out the 3 into y squared plus 2xy. Now 3 is going to cancel 3, so that this becomes negative into x squared plus y squared, bracket close, all over y squared plus 2xy, bracket close. With this, I hope you understand how to differentiate implicit functions. In our next lesson, we'll be looking at equation of tangent to implicit functions. To ensure you receive our next lesson, please do not hesitate to hit the subscribe button. That way, you'll be sure to get notified when we create our next lesson. So, till then, continue to stay fit and see you in our next.